So because statements have truth values, they also have probabilities. Right? So every statement is either true or false, either accurate or inaccurate. But we aren't always in a position to know whether a statement is true or false. Probabilities are just ratios that indicate the likelihood, our estimate of the statement being true. So this is Giuliano Cadamo, and he was an Italian mathematician who helped create classical probability theory. Right? And he's here primarily so I can do my terrible fake Italian accent. Right? I'm so glad you're asking that question. Probability for our purposes here is just a likelihood of something going to happen. Specifically, probability of a statement is just the favorable cases, the cases where the statement is true, divided by the total number of cases. Right? And so oftentimes that'll be expressed as capital P, parentheses, inside a symbol for the statement, right? And that's just equal to that favorable divided by the total number of possible outcomes. So because the number of favorable cases never exceeds the total number of cases, right? So F is never greater than N, the values for probability are always going to range between 1, F equals N, and 0. Right? A value of 1 means the sentence is true with absolute certainty. It is definitely true. Right? So if F equals N, then F over N equals 1. A value of 0 means that it's impossible for the sentence to be true. The sentence is false with certainty. All the values in between, intermediate between 0 and 1, represent the likelihood of the statement being true expressed as a value of the times it's true over all the possible ways the world could come out. And I have a little movie to illustrate that idea too. Right? So going back to those die, right? The probability of rolling a 5 is favorable, the cases where that die actually comes out as a 5 over the total number of possible 6 different sides, so 1 over 6. Likewise, right? The probability of rolling a 1 or a 3, that's 2 possible ways the world could come out to make that sentence true, and that means if I roll a 1 or I roll a 3, 2 different possibilities, then I get a true statement. So 2 divided by the total number of possible outcomes, again, 6 sides to a die, so 2 over 6 or 1/3. So now we know about statements, right? And arguments are just structured collections of statements. But what's the structure, as it were? Well, arguments break statements into 2 components, and then they make a claim about their relationship. Right? So statements are expressions of a language that have truth values and probabilities, and then arguments are going to structure those statements, talking about the relationship between 2 different collections of statements, essentially. Right? So when we think about argument structure, we're going to break those statements down into 3 components. On the one hand, we have the premises. Those will be all of the bits of evidence, all of the shared assumptions, all of the knowledge that we cite at the beginning of the argument. Right? Then there's the conclusion. Usually there's just one, right? But sometimes there's more than one. And the conclusion is the collection of statements, again, usually just one, that is said to be made more or less likely to be true given the truth of the premises. Right? So 2 groups of statements, and then the assertion, and oftentimes this is implicit, of an inferential claim, a relationship between the truth of the premises and the truth of the conclusion. And usually that is, if the premises are true, then the conclusion is. So when we think about arguments then, right, we have a collection of statements that are organized into the premises. And these premises are your claimed evidence, your knowledge, your shared assumptions, the things that you're assuming to be true in this context. Right? Your conclusion then, sorry about that, is what's claimed to follow from that evidence. And the argument, oftentimes implicitly, sometimes explicitly, right, makes that claim about that relationship. It says, if the premises are true, then the conclusion is guaranteed to be true, then the conclusion is more likely to be true, and so on. Okay? So arguments have a collection of statements that are the premises, a statement that's a conclusion, and an inferential claim that relates the truth of the premises to the conclusion. Now, that doesn't mean that the premises have to be true. It just means that the argument is making this claim that if the premises are true, the conclusion has the following truth value. So, well, now that we can think about inferential claims, we can think about two different kinds, fundamental classes of arguments, and they're broken up by the nature of their inferential claim. So we can think about a class of statements, all the highly probable statements, given what you know. We can think of another class, the class of all the definitely true statements, given what you know. And then we can think of a smaller class, the class of truths that you have available to you right now. Within that class, you can set aside a set of premises, evidence, assumptions. Right? And if you use a deductive argument, you make an inferential claim that your conclusion falls within that realm of things that have to be true, given what you know to be true. Right? So there's this deductive inferential claim. If the premises are true, the conclusion has to be true. Now, that claim only holds that the premises are true, right? But that's the relationship that's being asserted by the argument. The argument is asserting, look, this is what I hold to be true, and moreover, the conclusion has to be true if these things are true. Okay, so a deductive inferential claim. All deductive arguments make that inferential claim, whether it's explicit or implicit. What if I start off with things that are known to be true by me, right? And I make an inference, and that inference isn't to something that's guaranteed to be true, given what I know, but it's something that's highly likely, given what I know. Well, that inferential claim is what's called an inductive inferential claim. And so this kind of argument, an inductive argument, it makes a claim, look, if the premises are true, then the conclusion is highly probable. Now, what does it mean to be highly probable? Well, it's got to be significantly higher than chance, say, or significantly higher than was thought before. It's got to sort of give you an edge, right? And so an inductive inferential claim asserts a relationship between the truth of the premises and the conclusion, but this relationship is just that if the premises are true, then the conclusion is likely to be true, not guaranteed to be true, but likely to be.